look at how we can simplify polynomials. We're going to look at the different operations and some of the rules we have for simplifying. But first, we want to take a look at what if we have a polynomial with multiple variables in it. So in this case here, we have x and y both as variables in it. We talked about the degree when you had a single variable in it. You just took the exponent. But what if you have multiple ones? Well, when you have more than one variable, you count the number of variables in each term. So when you do this, you're going to count the number of variables, variable factors in each term and take the largest. So as an example here, in this term, remember we separate terms by plus and minus signs, so there's 1, 2, 3 terms, it's a trinomial. This first term I have 7 factors of x, 3 factors of y, that gives me a total of 10 factors. I have 6 factors of x, 1 factor of y. Remember, it's implied to be a first degree when there's not an exponent listed, so there's 7 factors here. 2 factors of x, 2 factors of y, that means there's 4 factors there. The degree of this multivariable polynomial is then just equal to the largest, which is 10. So now let's take a look when we're going to simplify it, some of our rules that we're going to use for doing simplification. First of all, let's look at our rules for exponents. We took a look at 2 of these in the previous lesson. We're going to add on to it a little bit. So to review, when we have the same base, we're going to add the exponents when we multiply here. So multiply 2 of these with the same base, you add their exponents. When you divide with the same base, both x, we're going to subtract the exponents. And then here, this is a rule that you might have been exposed to before, and we're going to explain a little bit, but the idea is if you get rid of all the factors, remember factors refer to multiplication, but if all the factors are gone, you're not left with 0, you're left with 1. So if there's no factors of x, you're left with a 1. Let me illustrate that over here with this problem right here. So if I use this rule here, what is x to the 5th over x to the 5th? Well, anything over itself is equal to 1. Well, using this rule, I'm going to have x to the 5 minus 5, which is equal to x to the 0. Well, we said that this was equal to 1 because they had the same in the top and the bottom. Well, that makes sense if you're talking about factors, because if you get rid of all the factors, you're still left with a 1. So anything to the 0 power except for 0 itself is equal to 1. And then our last new rule here is if you've got multiple parts to this with an exponent on the outside and these are being multiplied, notice this is x to the a times y to the b, then what you're going to do is bring the c in and multiply times the exponent. So this is going to be x to the a times c and y to the b times c. Let's illustrate that with this one here. Remember that this number 4, you're not going to multiply 3 times it. You want to multiply by its exponent. There's not an exponent listed. It's like it's 4 to the 1st. So you're going to bring that in and make it 4 to the 3 times 1. And then t to the 5 times 3. You're multiplying exponents when you bring it in. And then z, again, not listed there, so we're going to have 1 times 3. So that's going to give me 4 to the 3rd, which is 4 times 4 times 4 is 64. So we make sure that we simplify the numbers, put it to the 4 to the 3rd power, but then go ahead and simplify it because it's a number. We're going to have t to the 15th. And then lastly, we'll have z to the 3rd when we simplify that. So make sure that 3 comes in even to the number and put it as 4 to the 3rd power on that coefficient in front of it. All right, so now that we have some rules for exponents, let's talk about some other terminology. We use this phrase like terms or similar terms interchangeably. So make sure when you hear either one of them, you think of the same thing. The idea for like terms or similar terms is that similar terms have the same variables So when you look at the expression, they have the same variables in the term that you're looking at, comparing, and those variables have the same exponents. Same exponents as the corresponding variable in the other term. All right, so when we look at this, we're going to look at, for instance, if we had a problem like this one here. So we're going to look at this with adding and subtracting, but if you look at these different terms, okay, notice that this one here, this 8x, has the same, just x to the first as that term back there. This x squared has the same x to the 2nd power, same variables, and on those corresponding variables, the same exponent as that one there. This one has the same variable as these other ones, but it doesn't have the same exponent on it, so it's not similar terms with anything. So when we're adding or subtracting polynomials, you want to first of all combine similar terms. So on here, when we combine these similar terms, notice we can combine 8x and 23x, 19x squared, and negative 2x squared. We'll do that in just a moment. But one thing you have to remember when you're doing this, when you're adding or subtracting, you don't change the exponents. People forget that exponents refer to multiplication. When we're adding and subtracting, it doesn't change our exponents. So the exponents do not change when we're adding or subtracting. And lastly, we want to make sure, and this is when, especially when we're going to do a subtraction here. If it's subtraction, distribute the subtraction. That's something that people forget to do. All right, let's look at this one here. So we're going to combine like terms. I'm going to do the first one, I'm going to do it in order. Remember, you want to do it in descending powers order. So this negative 20 x to the 3rd can't be combined with anything. So I'll list it first because it's of the highest degree. Now the 19x squared and the negative 2x squared, I can combine those two. 19 minus 2 gives me a positive 17x squared when I combine those two like terms. Notice the exponent didn't change when I combined them. And then this 8x added to the 23x, I can add those two and I get a 31x when I combine them. So combine those coefficients, don't change the exponents when you're combining like terms. All right, so next what we want to do is do the subtraction problem. Notice I just wrote it in function notation to just get us back into the habit of using function notation. All this means is I'm going to substitute this in for that. So I'm going to have x squared plus 4x minus 3. and then I'm going to subtract the g of x. So make sure you put a parentheses around it because we're going to distribute through that negative. So we've got minus 3x squared minus 5x plus 2. Now what we're going to do is distribute that negative through. So rewrite the f of x, x squared plus 4x minus 3, minus that positive 3x squared will be minus 3x squared, minus a negative 5x will just be a positive, because minus a negative will be a plus, and then minus the positive 2 will be minus 2. Now we can combine like terms. Look for similar terms. So this one is similar to this one. So x squared minus 3x squared is equal to negative 2x squared. Then my 4x and my 5x are similar terms. So 4x plus 5x is 9x. And then lastly, my minus 3 and my minus 2, if I have these, which are like similar terms, negative 3 minus 2 is minus 5 for my final answer for that. So make sure you, again, distribute through the negative, and then you want to combine similar terms to it. Okay, let's take a look next at multiplication. So we'll go to the back side of your note sheet. We're going to talk about multiplying polynomials. All right, so multiplying polynomials will seem fairly similar to you. We've done these kind of multiplying a binomial times a binomial. But I want to show you a new way to interpret that. We've talked about the double distributed process. X times 3x, x times negative 4. In essence, what that was is x times 3x minus 4. We took that x and distributed it to the whole binomial, and then plus, this is a plus 7, so plus 7 times the 3x minus 4. So notice that becomes 3x squared minus 4x, which is just the same as if we did this, 3x squared minus 4x. That's why we do that process of distributing. And then plus 7 times 3x is 21x. 7 times negative 4 is minus 28. That's the same as doing these two multiplied through that distributed process. So really what we're doing is distributing those through in this, looking at it this way. And now we combine like terms, similar terms. 3x squared, negative 4x plus 21x is plus 17x, and then minus 28 for my answer. All right, so now that we've got, or we've tried the one that's very familiar, that we've done these before, what if we now have a binomial times a trinomial? Here you want to think of that idea of distributing every term in the first one to the second polynomial. So what I'm going to write is x times that second polynomial plus negative 5 distributed through to that whole polynomial. So when I distribute that, I get x times 4x squared is 4x cubed. X times 6x is 6x squared. X times negative 8 is negative 8x. And then negative 5 times 4x squared is negative 20x squared. Negative 5 times 6x is going to be negative 30x. And then negative 5 times negative 8 is going to be positive 40. Now, before I go and combine our similar terms, notice that this is just the same look as this. It's like we're taking the x times each of these. Notice that x times 4x squared is this term, x times the 6x is this one, x times the negative 8 is this one, and then it's negative 5 times each of these. So it's the same look to this, only you're adding a third term to multiply through, so it's going to be negative 5 times each of these as well. Now let's combine like terms. 4x cubed plus 6x squared minus 20x squared is going to be negative 14x squared. Negative 8x and negative 30x, those two are like similar terms, so I get negative 38x, and then plus 40. If you want, just as an alternative here, you can use the box method to multiply this out as well. If you like the box method, it's something that works for you, you can make it work here as well. How you write it is you write the x minus 5 here, and then here we're going to write this on the 3 spots here, so 4x squared, and then plus 6x, and then minus 8. Now multiply each of the boxes. 4x squared times x is 4x cubed. 4x squared times negative 5 is negative 20x squared. 6x times x is 6x squared. 6x times negative 5 is negative 30x. And then negative 8 times x is negative 8x. And negative 8 times negative 5 is positive 40. Notice that these are like terms, and these are the terms that add together. You get the 4x cubed, but then these two add to get this term. These two add to get this term, and then the 40 is left at the end. So you still have that idea of similar terms working through this problem to add it, even if you use the box method. So two methods, you can use the triple distributive here, or you can use the box method. All right, let's take a look at dividing polynomials. All right, so doing these, the key step for doing this is you want to separate every term in the numerator over the denominator. And simplify. This is our first look at division. We'll do a lot of dividing in this chapter with different problems, but the first one, you just want to keep it where you separate at the pluses, every term in the numerator. So I'm going to put the 8x squared y cubed over the 4x squared y plus the 24x cubed y over that denominator 4x squared y plus the 40x squared y squared all over the 4x squared y. So every term in the numerator gets put over that denominator. Now we simplify. 8 over 4, that reduces down to 2. X squared over x squared, that's just equal to 1, so we don't have to list it. And then y cubed over y to the first. Remember, you subtract exponents when you have one in the top, one in the bottom with the same base. And so I get y squared, because 3 minus 1 would give me the y squared for that. This one, I have the 24 over 4, which gives me a 6. My x cubed over x squared, 3 minus 2 is equal to x to the first, which is just x. And then y over y, the same, they're the same, top and bottom, that equals 1. Or if you just do 1 minus 1, that's y to the 0, which equals 1. So you can leave that 1 off. And then 40 over 4 is equal to 10. X squared over x squared is equal to 1, so we leave that off. Y squared over y to the first, 2 minus 1 is equal to just a power of 1. So this is simplified for that. So we've looked at a lot of information from our vocabulary for simplifying polynomials, and then we've looked at adding, subtracting, multiplying, and dividing them, and how do we use those rules to simplify our polynomials using those rules.